All right, so today you guys are going to learn a little bit about 9.2, which is analyzing data displays. Okay, learning target at the top there is to interpret the data displayed in dot plots, box plots, and histograms within the context it represents. So we're going to be learning how to make each one of those and to read it from there as well. Okay, so first one, example one says Manuel plans to buy a new car with the gas mileage shown. To determine if the gas mileage of this car is good, he gathers data on the estimated city driving fuel efficiency in miles per gallon of several other cars. How does the fuel efficiency of the car he wants to buy compare to the fuel efficiency of the other cars researched? Okay, so the biggest thing here, learning in this part with the dot plot, right? So that's the first one we're going to work on, okay, is that Manuel wants to compare individual values, okay? So individual values goes here. That's what you're looking for when you're trying to decide which one of these you're going to be using each time, okay? So a dot plot is a good way to show that information, all right? So dot plot for individual values. Create a dot plot of the data by first drawing a number line. Okay, a number line that includes all of the data and represents the range of the data. So from the biggest to the smallest, right? So maybe from here, big. I'm sorry, I shouldn't have put that. I should put small to big because that's the side it's going to be on. I'm sorry about that. So small to big, right? It's like the smallest number to the biggest number. Then we're going to plot each value from the table as a dot above that number on the number line. Okay? So here's our table of values right here that we're going to use. All right. We can see that the biggest number they give us is 46. All right. Which is, oh no, I'm sorry, 45, which is right here. Okay. And then the smallest number that we see on here looks to be 25, right? Right above it. Okay. So this would be the left side, and then you'd have the right side as well. So I'm just going to draw a little line here. If I can find my. Find my shapes. Okay. All right. So I'm going to go. Do the line, and then we'll do arrows on both ends, okay? And then we'll go back to the pin, and we'll go ahead and fill this in. So I'm going to go from 25 to 45, okay? So 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 39, 40, 41, 42, 43, 44, 45. Made mine a little big, okay? All right, so I'm going to start. I'm just going to do every other number so that it fits. Okay. 31, 33, 35, 37, 39, 41, 43, 45. Okay. And then we're just going to go over here, and literally every time we see a number, I just usually like to either cross them off or check them so that you know you've used it. And you're just going to put a dot right above that number. So 25, I'm going to put a one dot right above it. Then I've got 45, so I'm going to go all the way down here for that one. 26 gives me one dot. 35 gives me a dot. 31. 26 again. 30. 28. 29. 26 again. 28. 26 again. 27. 27. 28. And 28. Okay? And there you go. That's your dot plot. So super easy. Just make sure all the numbers are included and put a dot above the number as you get it, okay? So then it says, do you notice any outliers? Okay, remember from our other day, outliers are numbers that are way bigger or smaller than the ones that you have in your data set, right? So if you notice, we start at 25, right? Most of the data lies right here in this area. 35 is just a few more, and then you've got all the way down here to get to 45. So this guy would be your outlier, right? So dot plots are the best option. Okay, this would be, sorry, I skipped that part. Yes, 45 is an outlier. Okay, much bigger than the rest of the data. Okay. All right, so then what could be the explanation for an outlier? Well, we're talking, remember, about Manuel who wants to compare new cars, right? And how fuel efficient they are. So if you have something that gets a lot more gas mileage than another one, maybe it's an electric car, right? Like maybe it's a Tesla. So maybe an electric car or one of the hybrids, and the rest of them are just regular gas. Um, and that's the explanation possibly for why that one gets way better gas mileage than the other ones. Okay? All right, so just keynote down here. Dot plots are the best display option for showing individual values. Okay, so values for each and every single thing by themselves, so you can see where they're at, and where most of the data is clustered. Okay, so kind of grouped together. It is not easy to identify the center of the data using a dot plot because it's all kind of grouped together there. All right, so that's the hardest part for that. But otherwise, comparing individual is the best one. Okay. All right, so on to the next one. Represent and interpret data in a histogram. Okay, so let's change here. Histogram is what we're looking at this time. And let's read what it says. A marketing team is about to launch a campaign for a new product that is targeted at adults aged 25 to 34 years old. The team is researching the age range of viewers of a certain TV show to decide whether to advertise during the show. The data shows the ages of a random sample of 30 viewers of the show. Based on the findings, should the marketing team launch their campaign during the particular show? Okay, and that chart came out a little bit funny, but those are ages, right? Like this would be, this one here is 14, 21, 22, right? So just so you kind of know what that means, okay? All right, so if you're going to use a histogram, okay, histograms are often used to represent data over ranges of numbers. So they don't give us an exact number to look at, but they said that they want their range to be 25 to 34 years old, right? So that's when we're going to use a histogram, when it's a range of numbers, like a group of them, okay? To create a histogram, first decide on an appropriate interval or intervals, okay, for the data. So intervals are like what you count by on the graph, okay? So you have to decide what are you going to count by that makes sense, okay? Then create a frequency table. So how often something happens to organize it. And remember the intervals must be consistent, right? Which means you must keep them the same throughout the whole thing. You can't count by twos and then skip to 5 and then skip to 3. It has to be the same thing over and over again, okay? So there should be when we're talking about intervals, how you choose your intervals, okay? So this question kind of goes here. There should be multiple values in each interval, okay? You don't want to have them so broken up. Oops, that's the wrong word. You don't want to have them so broken up that you only have like one in each one, and you don't want to have them so close together that you can't really see where the breaks are. So they have to be kind of spread out in a way. All right. So for this one, if I'm going from 25 to 34, and we're looking at, that's what they want us to look at. And we're looking up here at our data set, right? And the smallest age range that I can see here is 14, right? And our biggest one looks to be 30, 37, I think, right here. Okay. So 14 to 37, we probably want to break it up maybe in groups of 4, okay? Or 5s maybe, starting at like 10 to 14. It looks like there's a lot of 14. So let's try that first, okay? So I'm going to make my frequency table to see how many are in each group, okay? So I'm going to do 10 to 14, 15 to 19, 20 to 24, 25 to 29. We'll do 30 to 34 and 35 to 39. That'll cover all the way to 37. Okay? So I'm just going to make a little table here, and I'm going to put a little tick mark every time I have a number in that category. Okay? So I'm going to start up here with 14. All right? So 14 is going to go here. 21 goes here. 22 also here. 17 would be in the next one. 24, 20, 26, 15. Oops, nope. Gotta be careful. Got a little bit of hurry. 15, 20. That's my fifth one. 22, 14, 24, 26, 15, 17, 21, 32, 30, 16. That's the fifth one there. 31, 25, 20. There's a lot of values. 19, 16 would go here. 21, there's 10 for that one. 37, 17, 20, 15, and 16. Okay? All right, so then once you have your frequency table, now we can go down and actually use it to help us create our histogram. So a histogram is basically like a bar graph, but it shows you have to make the frequency table first to be able to make the histogram, okay? So when we do a histogram, we're going to have our categories. So these are all going to be our X values, okay? So they're going to be down here. I'm going to have like 10 to 14, 15 to 19, and we're going to repeat those all down here. 25 to 29, 30 to 34, extend this just a little bit more, 35 to 39. Okay, so this is going to be the ages, and then the frequency of how often they happen is going to go over here, right? Well, our frequency, this one has 2, this one has 10, 11, 3, 3, and 1, right? So I'm going to kind of, the biggest one I have to have up there is 11, so I'm just going to count by 2s. 2, 4, 6, 8, 10, 12. Okay? And then I'm just going to draw my bar. So first group has 2, so I'm going to come up here. I'm going to draw a bar for 2. 15 and 19 has 10, so I'm going to go up to 10 and over. Histogram bars touch, so there's no space between them. 20 to 24 has 11, so I'm going to go up just a little bit more. 25 has 3, so between 2 and 4. 30 to 34 has 3, and this one has 1. Okay? All right. Then it says What age group, so this one here, what age group would be a good match for the products advertised on their show? Well, that would be the one that has the biggest amount in it, right? So I would say 15 all the way to 24-year-olds. Okay, because that pretty much picked up the most of our data. All right, and then if we go down to the bottom, it says, what are other possible intervals and how would a different interval change the way the histogram displays the data? Okay, well, I mean, there's lots of possibilities here for this answer. Another one is if you were going to do, like I said, the age range we had was like 14 to 37. So, I mean, you could do intervals of 10. Now, if you did intervals of 10, right, we'd have like 10 to 20. Well, 10 to 20 would have all of this group in it together, right? And then if we did 20 to 30, that would break up to here. And then 30 to 40 would be here. So you can see that it would only have 3 bars and it would look like there was a lot less in one group as another. Okay. And probably a majority of them would be from the 20 to 29 group instead of being in the 15 to 24. So it would be a smaller age group as well. All right. Okay. So box plot is next. All right. Hang with me here. There's a lot of information. Okay. A box plot says students at a local high school organized a fundraiser for charity. Caitlin, the student council president, announces that more than half of the students raised over $50 each. Okay, again, more than half of them raised over $50. The amount of money raised by a random sample of 24 students is shown. Does the data support Caitlin's claim? Okay, so Caitlin's claim is about the distribution of values. Okay, so how much they're spread out, right? So a box plot will reveal the information that we need. A box plot shows the distribution of data using a 5-number summary. Okay, so here's what those 5 things are. The minimum value. Okay, well, this should be pretty easy. The minimum value is the least or the smallest value in the set, right? Then next would be the maximum value. And the maximum value would obviously be the greatest value in the set. Okay, then we have the median. You guys have all heard these words before for several years. The median is in the middle, right? We just talked about these in the last one. Okay, and then these last 2 are ones you probably haven't talked about for a while. So these are called quartiles. The first quartile, and you kind of hear the word quarter in there, right? That means the first fourth, right? Is the middle number between the minimum number and the median. Okay. Then we have the third quartile, and that is the middle number between the median and the maximum number. Okay? So, what we're going to do in order to get all of those happening, the min, the max, the median, the first, and the third, right? To get all of those, we have to figure out what the data is in order. So we have to take all of these numbers from this chart up here, okay, and put them in order from least to greatest. And again, I would check them off as you do them, make sure that you don't have any leftovers, and then kind of space them out so you're able to see. Okay, so I'm going to get started here. You can't see the list up there, but you have it on your paper. So we're going to start with 25, and then we've got 2 of those. We have 26, 27, 31. Then I've got two 32s. Okay. 36, 38. Then we have two of the 42s. 45 has 3. It's important that we list all of them, even if they repeat, because that gives us the middle as a different number if we don't. 48, 49, two 50s, 3 of the 54s. 1, 2, 3. Then we have 55, 59, and 68. Okay? All right, so let's label these, right? This guy on the end, right, would be our minimum. Okay? Then I have our maximum out here on the other end. So min and max. Okay? We need the middle. All right? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 is an even number, so we're going to have to split it in two, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means our line is here, okay? That's the middle. So then we're going to have to take these two numbers, add them together. So 45 plus 45 divided by 2. Well, the middle of 45 is still going to give us 45. So 45 is still our median. That's the middle. Okay. And then we have to find our quartiles. So again, our quartiles are the middle between these sets, right? So I'm going to break it in half. So between this first set over here, all right, and again, there's 12 there. So we're going to go 1, 2, 3, 4, 5, 6. Here's my middle. Well, 32 and 32, the middle of that would still be 32. So this is my first quartile. Okay. And then over here, 1, 2, 3, 4, 5, 6. So my middle is here. And then if you 50 and 54, well, halfway between that would be 52, right? So this would be my third quartile. Okay. All right. So we have all 5 of our numbers. And now we're going to create a box plot. Okay. So to do that, we have to start with a number line that includes the numbers that we have circled up here. Okay. So first thing I'm going to do is make my number line. Okay. Come down here. Have that. I'm just going to count by tens because it doesn't have to be exact. Okay. So go back here, grab my black color, and we're going to have just 20, 30, 40, 50, 60, 70, 80, and we'll stop there. Okay. We could go on for a while. So 20, 30, 40, 50, 60, 70, 80. And I could have spaced those out more. It just makes your box plot even bigger. All right. So then we need a dot above each one of these numbers up here that we listed so we can create our box. So 25 is the minimum. Well, 25 is going to be about halfway in between 20 and 30, right? So I'm going to put a little dot here. Okay. Then I'm going to need first quartile at 32. So I'm going to go, if this is 35, I'm going to go 1, 2. So pretty close to that, right? Okay. Then my median is at 45, so halfway between there. I'm going to put a little dot there. Then I'm going to have my third quartile at 52, so close there. And my max is 68, so almost to 70. Okay. So the box is actually going to be in the middle. So we're going to draw little whiskers. I always call it, these are always whiskers. out here on the side. We're going to make a box in here. Sometimes they call it a box and whisker plot. There's that, and then where this line is, we're going to cut that right down the middle. Okay? So again, this is our minimum. This is our first quartile, right? This is our median. This is our third quartile, and this is our max. Okay? So, what does the interquartile range represent in the box? This guy over here, that would be the actual like shaded region in the middle. So this would be like this part here. Okay, that's the interquartile. It's between the quartiles. All right, so that represents 50% of the data. Quartiles mean quarters, you guys, right? So this would be like 1/4 here, 2, 3, 4, right? And so 2 of the quarters would make 50%. Okay. What can you determine about the data by looking at the size and shape of the box that represents the interquartile range? Well, more values are less than the median than are above it, right? Because the bigger chunk is on this side of that line. This is the median, yeah? So if more is on the left, that means that more values of our data are on the left side, which means they're smaller, okay? If they're on the right, then that means they're bigger, all right? Okay. So if we finish up here, okay, a box plot clearly shows that half of the data are below the median and half of the data are above. Okay? All right. So, I'm sorry, I skipped this guy up here. Can you use the box plot to determine what percentage of students collected more than $50? Okay, so 50, right? The box plot shows 50% of the students collected more than 45. So 45 is our median, right? Okay. And we know that 50% of the students collected more than 45, but we can't really show that they collected more than 50. So this would be no. Okay. We know that this is 52 and 25% collected more than that, but we don't know the exact amount that collected more than 50. All right. So this would be no. 25% collected more than $52. Okay. But we can't really see how many exactly collected $50. Okay. We have one more here to go. All right. And this has been a long notes. I appreciate your patience here. All right. Helena's dance team scores 68 points at competition. The scores for all the teams that competed are shown. Helena wants to know what place her team finished. Should Helena use a dot plot, a histogram, or a box plot to display the data? Okay, well, she wants to know her team compared to everybody else's. So she's looking at individual scores. And if you're going to look at individual scores, then you should choose a dot plot because it's going to show you all the exact ones. Okay, dot plot for individual. What place did Helena's team finish in the competition? Well, in order to do that, we have to actually make a dot plot. Okay, so you would need to draw your number line. I'm going to let you guys do this part. But you would need to draw your number line. Okay, and the number line would have to be everything greatest to least that you have here on your data values. Okay, so the smallest one is 65 and the biggest one they give, oops, I'm still on the thing, 65, and the biggest one they give us is 90. So your dot plot needs to go from 65 all the way to 90. Okay? Now, once you do that, remember, you just take and put a dot above each one of the numbers that you have listed up here in your chart. So this goes with this one down here. Okay? Then we're going to say, which data display should Helena use if she wants to know what percent of the team scored higher than her team? Well, percentages are always on a box plot. Okay? So they show the first and third quartiles, which are going to show you what percentages, right? Like 25, 50, 75, that there are in order to show percentages. So box plot's always going to be what you use for percents. Okay? All right, I think that just about does it. So it says the information I get about data sets from different data display is dot plots, right? Frequency of data clearly indicates clusters, gaps, and outliers. So along with box plots, which is distribution, right? And then we have the box plots, which give you percentages, okay? And clusters of data by those quartiles. All right, let us know what you have questions on. Lots of notes. Thanks for hanging with.